Hi everybody, and welcome to the Azure Fundamentals training course. Today is the first of two key modules that we're going to be covering to take you guys up to the level of getting you certified to be able to sit the Azure Fundamentals exam, and also to have you competent, to have a good understanding of what Azure is and how you can use it. So we're going to go through a series of introductions, then we're going to do an overview of some basic cloud concepts. These do come up in the exam, so it's worth paying attention to that stuff. Then we're going to do a demo. I'm going to show you guys around the Azure portal, to give you a chance to understand what's in there and the sort of stuff that Azure is capable of, but also to try and set the story about how Azure helps in terms of provisioning the infrastructure that our applications will run on. Then we're going to take a look at some of the core services that Azure offers, the sort of things that we can build in Azure, the sort of things we can use to accelerate building our solutions. Then towards the end, we're going to wrap up with a demo of Azure Artificial Intelligence. And the reason why I like to give a demo of Azure AI is because it really does show the story of what the art of the possible is with Azure, but also as well, it's a very good opportunity for you to see just how achievable the art of the possible is and just how easy Azure will make your life as a software developer and as an infrastructure person. Then finally, when we wrap up, after this course today, there's going to be an exercise that I'd like people to follow through, which is all about getting your own Azure trial subscription up and running. So you can have your own Azure sandbox. So you can go through some labs that we're going to issue out in the next module. So you'll be ready to hit and run that stuff. So this is what we're going to cover today. So let's start off with Module 1, Lesson 1. The first course is all about Azure Fundamentals. We're going to cover everything that you need to know and you need to be able to do to work with Azure. The whole point of this first course is to get you guys ready to sit and pass the AZ-900 exam. In this first module, we're going to cover some core Azure cloud concepts. Then we're going to take a look at Azure services. Next week, during Module 2, we're going to start driving into security, privacy, compliance, and trust, which is really important. If we want to bring people onto this platform, we have to be able to demonstrate that it's a trustworthy platform and that we're capable of operating our workloads on there. Then in Module 2, we're going to take a look at the final side of content, which is all about Azure pricing and support. So that's all about the things that we need to add into Azure to make sure it's paid for and there's support available for it. So kind of the logistics in that bit. In the third and fourth modules, which we're actually going to merge into one, we have got two sets of labs, which is steered around giving you guys some really hands-on experience. Now in these modules, what I'm going to do is run through the briefing for the lab and just quickly do an overview of it for you. So you'll see me actually doing the labs. Then what you guys can do yourselves is after the module completes, you can go away, follow the notes that we're going to give you to run through those labs and get some real hands-on experience with Azure. What you're going to see is rather than just giving you labs where you're going to be doing some fairly namby-pamby things, in these labs I'm going to get you to do some quite real-world stuff, like creating virtual machines, deploying workloads to those virtual machines. I'm going to give you an opportunity to get into Visual Studio and to be able to create a very simple application in Azure, in Visual Studio, and deploy it as a cloud service to an app. So you're going to come away from this course with some real serious hands-on experience that will give you a flavor for the sort of things you can do with Azure. Rest assured, I'm making the assumption that the people on this course don't know anything about Azure already and that they're not coming to this as experienced software developers or experienced infrastructure people. So these labs will be from the ground up. Point is, by the time we finish this course, you should be ready to sit and pass the Azure A900 Fundamentals exam. With that in mind, what is on the AZ-900 exam? So the AZ-900 exam is structured around 4 areas, and funnily enough, they map directly to the modules and the lessons we're going to teach on this course. So again, it's about understanding the cloud concepts. What is the cloud? How does Azure fit into the concept of what a cloud is? Azure core services, what are the things you can build on Azure? What are the things that Azure does to make it easier for you to host and run services? Security, privacy, compliance, and trust, that's quite a big module. And that's a module where you're going to learn how Azure makes it a secure place to host workloads. And then finally, we're going to take a look at pricing and support. Now, those are the subject areas that you need to be proficient in to pass the exam. If you look at this rather dainty pie chart that I've put together here, you can see pretty much it's an even spread of knowledge you need across these areas. So in the 50 questions you'll face in the Azure exam, you can probably expect to find about 15 questions, 10 to 15 questions on each one of those areas. The Azure certification exam for fundamentals is quite straightforward. That's the good news. The certification exam is obviously AZ-900. You can sit that in one of two ways. You can, as you would do traditionally, go to a testing center, book in for an appointment, go along, and everything will be set up for you. If you prefer, what you can also do now is you can sit this exam at home as a proctored exam. What that means is you get your own laptop, you install some software that Pearson Prometric give to you, and you actually sit the exam in your own house at your own time. You do need to be in an isolated room or an office, so if you want to do it from work, you can always book a meeting room and do it in there, as long as you're going to be interruption free and you're not going to have any other computers or textbooks in that room, you'll be fine. One certification exam will get you the credential of Microsoft Certified Azure Fundamentals, or MCAF. Microsoft have this new structure for their certifications now, where there are 3 levels of certification. Fundamentals is the first level, it's an entry level, and for that you get 1 star. The next level is the associate level. That's metaphorically the equivalent of what used to be like the Microsoft MCSE level. So an associate is somebody who's an experienced professional and is very proficient with the workloads. The 3rd star level of certification is expert level, and that's kind of like the 3-star level. So as we go through this program, beyond the Azure Fundamentals course, we're also going to be delivering the modules to get you guys through an expert level qualification and an associate level qualification. But it all starts here with AZ-900. Now this exam isn't mandatory if you're going to just sit the further exams that come further down the line. You don't need to get a 1-star qualification to achieve a 2-star or a 3-star level. However, it is in the best interest of you for your own career and for DXC for our certification, our partner certification status with Microsoft, if you guys do go and sit this Azure Fundamentals exam. I can't encourage you enough to get out there, have a go at this exam, do the training course, get through the exam, and if nothing else, this will give you a level of credibility and confidence in yourself to go on and achieve the higher levels of certifications. And most importantly, this helps us continuously demonstrate back to Microsoft the level of investment we're making internally in training and readiness, but also as well our capabilities and our trustworthiness to be running and delivering Azure solutions for Microsoft's customers. That's the waffle out of the way. Now we get on with some real technical content. So in this lesson, we're going to take a look at some core cloud concepts that we need to be able to articulate in the exam. So between 15 and 20% of the exam, there are 3 areas, and this equates for about 15 to 20% of the exam. We've got the idea of needing to be able to articulate some fairly simple concepts, such as high availability, scalability, fault tolerance, DR. We need to be able to understand the principles of economies of scale. So how is it possible for Microsoft to deliver scale faster and cheaper than we can do ourselves on-prem? We're going to take a look at the 3 main architectures for hosting, which is infrastructure as a service, platform as a service, and software as a service. So those of you who've been around the cloud computing space or have ever read any marketing materials ever in the last 3 to 4 years can see there's a little waterline diagram coming along there. It's essential for the exam that you're able to understand what differentiates an infrastructure as a service offering from a PaaS offering, but most importantly to appreciate where the separation of roles and responsibilities lie there. And finally, we're going to finish off this lesson by talking about 3 different types of cloud architectures we can deploy. So we have private, public, and hybrid. And again, the real trick for the exam is being able to understand the differences between those characteristics of those architectures and which ones to choose for our customers. One of the biggest questions that I'm continuously asked by customers is, where do I get value from Azure? Does Azure save me money? Now, if I was to take the mindset of saying, I've got 300 servers in a data center today, I'm going to migrate them and run them on Azure, will things get any cheaper? Well, I think, to be honest, I wouldn't save any money by doing that because I still have costs. Okay, I'm going to break away from the model of having to periodically come up with large sums of cash to buy new storage and hardware, but this stuff still has to be hosted, it still has to be run, and there are still costs for it. If you just take stuff and migrate it into Azure, your organization isn't going to save anything. Where an organization is going to make some serious changes and is going to get some serious benefit from it and actually save money is by becoming more agile. So as we talk about the things we're going to do within Azure, we're also going to talk about some of the things we need to do as we manage Azure. So there's a tool set within Azure that's used for day-to-day management of traditional infrastructure operations like backup, recovery, disaster recovery. But the thing that really sets Azure aside is the idea of Azure DevOps and agile computing, agile development. Azure DevOps is what used to be called Visual Studio Team Services. And what that means is we've got a tool set in place that allows developers to be able to write their code and then deploy those solutions directly onto Azure using the Azure DevOps toolkit. Because it's based on Visual Studio, it's the tool software developers are used to working with. This is what makes things really powerful. One of the key principles of cloud computing and agile software development is you never truly treat an application as finished. It's what we call continuous development and continuous delivery. So the idea is over time your needs change for the application, and over time the platform and capacity you need for that platform will change. So this gives us a mechanism to be able to, so Azure gives us a platform to provision the infrastructure these workloads on. Azure DevOps gives us the capability to be able to deliver applications onto that infrastructure. And with that comes the ability to become incredibly agile, deliver more value for the business, but also as well to truly gain a solid understanding of the performance and capacity of our applications and drive down the capacity we consume over time. A lot of that will come by right-sizing applications, maybe changing things to using a smaller virtual machine or choosing the right tier of storage to run on. But the real savings come along in moving people from an infrastructure as a service offering where we've just taken virtual machines and moved them into Azure and moved them up towards maybe using platform as a service or software as a service offerings that are just significantly more cost effective. I'm sure pretty much everybody on this call will have seen this slide or a slide just like this. If you've been exposed to any kind of marketing from Microsoft or VMware or pretty much any of the vendors or Amazon, you'll have seen a slide deck like this. This is what we call the waterline slide. So if you take a look at a data center today where we're running things on-prem, what are our responsibilities to look after and manage? We've got to take care of everything. Even beneath where this diagram starts with networking at the bottom layer, we still have to provide a building, facilities, air conditioning and so forth. Then we've got to provide networking, storage, hardware, virtualization layer, an operating system, middleware, a runtime environment, data and applications. That is all our responsibility to run. So if you imagine that, you require buildings, facilities, hardware infrastructure, operating system support, so systems engineering, developers, operations, that whole platform, we need to source that ourselves. If we move to an infrastructure as a service model, we are changing the structure of how we're operating stuff. So where some of these savings come from is it's much cheaper for Microsoft to be able to buy hundreds of thousands of servers, because if this organization is buying in bulk, they get stuff cheaper. If they're managing and operating this stuff and automating this stuff, it's cheaper for them to operate. That brings down the cost slightly, but where a lot of the cost savings from moving to infrastructure as a service come from is you no longer have to be bothered about designing, developing, and configuring a virtualization tier. You don't need to worry about physical servers, storage, or networking. You don't need to worry about scaling the stuff. We're just taking what Microsoft gives us and we scale it and we work with it. All we're responsible for doing is creating a virtual machine object in Azure, deploying an operating system in it, and the software that's going to run on that platform. The next level of maturity or evolution for that is where, well, actually, let's treat the runtime, middleware, and operating system as something that is just a commodity. If we develop our applications in the right way, it should just be able to run in a fairly generic environment where we have some ability to customize it. But the idea around platform as a service is I don't have to care about the operating system I'm running on. All I need to know is that I've configured a runtime environment, which is the place where my applications are going to run in a way that supports my applications. I then can spend my time worrying about the data and the applications that are in there and managing that. So, in this case, the case of Azure, Microsoft will take care of those underpinning components for us in red. We focus our time on developing applications and looking after those applications and what they do to deliver value to the business. The fourth model is software as a service. So a key example of software as a service is Office 365. We think back to maybe 10 years ago when people went out and implemented email for their organization. They would go and they would build some servers, connect them to the network, install an operating system, install Exchange Server, and they would own and maintain and operate mailboxes on there and configure that service on-prem. With Office 365, what do you need to do? Well, very little. You need to say which users need to be enabled, and you need to say what size mailbox they want. And Microsoft take care of that whole application for you. When it breaks, they'll fix it for you. When it breaks, you tell them what's not right with it. And ultimately, you move from this model of having lots of infrastructure to maintain into a world where you've just got to concentrate on what you want to use that platform for, and it's there and supported for you. So for us as an organization, DXC, we used to live in the space of that first pillar there, the on-premises world. That was where we added value. We would provide data centers for people. We would host the stuff. We would design and implement that stuff. As people start moving forward towards IaaS, platform as a service, and software as a service, the question we have to ask ourselves is, as DXC employees, how are we going to add value to our customers? How does DXC become stay relevant in a world where everything's hosted from a Microsoft data center? And the answer is threefold. Firstly, not everything is going to be able to be migrated to Azure for a number of reasons that we'll talk about later on. There's always going to be a need for some level of hybrid computing where some servers and applications stay on-site, some live in the cloud. The next part of the answer is somebody needs to manage and maintain that Azure infrastructure for them. And this is the role that we would play as a managed service provider. And the idea there around being a managed service provider is we'll take care of configuring the things in orange for the customer, and we'll actually run and operate the things in blue for the customer. And then finally, the last area where we can really add value is around being what's called a cloud service provider, which is where we take ownership of the entire stack and the billing for these services and operate that in conjunction with Microsoft. And we become the customer's provider of Azure for them. We provide the customer with Azure resources, we handle the billing for them, we handle the support for them, and we become effectively not just a middleman, but a huge value-added player that sits in between the customer and Microsoft. So in some cases, what we should be doing for our customers is driving them along on an evolution story where they go from being on-prem towards IaaS, then up to platform as a service. And in some cases, moving them from platform as a service up to software as a service as well. In an on-premises world, storage was always a very, very tricky subject. People used to earn a lot of money as a storage architect. Organizations became very, very rich and powerful by having really good storage offerings. And there were some general challenges that people face with storage. Usually the first one is, I need to be able to store my data in a way that's reliable. So if I lose disks or appliances or buildings, I don't lose my data. I need to be able to archive data to make sure it's historically available. I need to be able to tier my data, so the stuff that needs to be fast is readily available. The stuff that I only need to get at periodically, that can go into cheaper storage. I need to be able to replicate it around the world. I need to be able to back it up. So for most enterprises, that kind of solution used to look like a large storage area network. And it was always painful because you would get to a point where somebody needs to add another disk into a SAN, or somebody needs to add another shelf of capacity. The beautiful thing about Azure is Azure provides some really powerful storage blocks for us. Not only do these storage options scale right up to cope with huge amounts of data and huge amounts of throughput, and to provide some really graceful options around continuity, but it also scales right down. So as a company with, say, 5 employees, I can have a truly high-end storage solution that provides me with disaster recovery, fault tolerance, high performance or low performance, whatever I need, and replication. And because I'm paying per gigabyte of storage, that's accessible to me rather than having to go through this foundation of finding several £1,000s to buy a SAN and bring that in. So when we look at Azure, there's 3 things we need to know about fault tolerance for storage in Azure. Pretty much everything we host in Azure is going to consume some level of storage. In the case of virtual machines, the virtual hard drives that run our workloads, that will run on Azure storage. All Azure storage is it's within the Microsoft data centers. There are storage appliances with hard drives that are divided up and isolated and presented in terms of capacity to individual customers. So there are these things called storage accounts. And what we can do within a storage account is create a container. So storage gives us the ability to store files. We can create blob objects, which are basically just large areas of binary where we can stream data to and keep image files and so forth. Table storage, queue storage. We'll talk more about these later on in depth, but the idea is we have these ways of storing our applications data. We can create file shares in Azure storage as well. So a file share would be something that we can map a drive to it and work on it throughout our operating system. But the majority of storage scenarios that Azure Storage works with are about providing capacity for virtual hard drives to run from, or for allowing our applications to be able to store data in directly. When we create storage in Azure, we need to choose a location for that data. So Azure is structured with a global chain of data centers around the world. We'll run through where they are and what they are shortly. But it's vital we choose the right location for our data to be stored in, because most organizations will probably have to make some commitments to governing bodies about where our data resides. If I choose to store my data in a particular Azure region, I can guarantee that it's not going to move out of a geographical area. So I can underpin, data sovereignty issues. So if I say my data is hosted in the United Kingdom, there's 2 data centers in the UK, under no circumstances will Microsoft move my data outside of the mainland UK. There's similar boundaries around the European Union, similar boundaries for individual countries. So France and Germany have their own regions, and in America and the Middle East there are regions there. So the first decision you need to make about data storage is which region are you going to host this in? So we need to choose the base location for our storage. Then what we need to do is choose what performance tier we want. Do we want to use the standard tier, which will give us a moderately high level of input-output operations per second, a fairly high degree of performance which will suit most workloads? Or do we want to use the premium level of storage? Now, this is something that will quite often throw people, especially in the exams. If I create a standard storage account, I'll have the ability to be able to create blob containers in there, queue containers, file containers, and file synchronization containers in there as well. If I move up to the premium level of storage, though, I start losing options. If I move my storage from being standard and I just want to make it a premium account, I am going to get much more performance from it. I'll still be able to get access to a much higher level of input-output operations per second. I'll have the ability to be able to read and transmit data to and from that storage much faster. But I'm going to lose options as I move up to the premium tier. So for example, if I want to create queue storage or table storage, I can only do that in the standard storage tier. And that's because there's only so many transactions that they can support in the standard. So we can only do that because of replication considerations. If I move up to the premium tier, I'm also going to use the ability to be able to do replication. So if I'm paying for really fast hard drives that can read and write data to you very, very quickly, I can't get that higher level of disk performance and still guarantee to be able to replicate my data around the world. So when I'm choosing my performance tier, I need to say, okay, if I'm buying standard, I want to have the most level of capabilities with a reasonably high level of performance. When I'm choosing premium storage, what I'm doing is I'm going to pay more money for the storage. I'm going to lose some of the options of what data I can keep in there, and I'll lose the replication.
Recording has started.
But what I will have is much higher levels of performance. So you use premium storage sparingly. You use it for scenarios where you've got to be able to get lots of information quickly into and out of storage. Azure gives me a choice of the types of storage account that I use. There are two levels of storage account I can use, which is where I have a general purpose storage account version 1, which is created using a legacy deployment method within Azure, or I can use V2, which is the modern version. The V1 option only stays in there for backwards compatibility. There is also a blob-only storage account, which makes things a bit cheaper for us, and that only allows us to provide blob storage. But that does give us some much lower costing options for application data hosting. Then finally, what we need to be able to do is to choose the replication level that I want with this storage. When I create a storage subscription, not only am I buying the capacity that I need to be able to write that data to, a bit like sizing a hard drive, but what I'm also doing as well is getting a bunch of replicas as well. There are 4 levels of replication available within Azure Storage. The entry-level offering is what we call locally resilient storage. So within one data center building, Microsoft will provision my data drive, and they will also provision 3 replicas of that data. So ultimately, there are 4 copies of my data now. My main copy and then the 3 copies that are held. Now, all 3 of those copies live within the same data center building. We're not getting much in terms of resilience. We can survive the loss of a physical disk. We can survive the loss of a storage appliance. But what I can't do is survive the loss of a building or a region. But I'm making sure all my data stays in one place. Locally resilient storage is the only level of storage where I can run certain storage container types, like table storage and queue storage. And the reason why is because when we start replicating that data out elsewhere, because we've got to replicate the data, we lose the kind of performance that we need to be able to show we can commit writes to the drives other locations. The next level of resilience we can choose to buy is zone redundant storage. And what ZRS does for us is, as well as having the 3 copies of data that are made for us in one data center, they take some of those copies and separate them around different data center buildings in the same region. So in Azure terms, a zone would be an area like UK South, US North. So if I've placed my data in that region, I can guarantee it's going to stay in that geographical region. Because it's zone resilient storage though, my replica is going to be spread out across multiple data center buildings in that same geographical area. But yes, I can guarantee if I've chosen US North as my location, my data is not going to leave that that geographical area, but it will be spread out amongst multiple data center buildings. So because that data has to be replicated amongst multiple data centers, there's a little bit of a latency included in the time where we replicate that data around those buildings. But what that means I can do is I can survive not only the loss of a physical disk, I can survive the loss of a storage appliance, but I can also survive the loss of a data center building. The next level up from that is what we call geo-redundant storage. And the idea around geo-redundant storage is we're saying my data is really important and it's vital that I can survive the loss of an entire geographical region. So the idea would be there, if my data lives in UK West and I enable global resilient storage, my data would then be replicated across to another region, probably in the same country. So we might replicate our data from UK West to UK East. What happens there is if I lose the data centers in US West, there'll be a copy of my data left in UK West that I'm able to take and use at that point. The final level of resilience we could buy, which is also the most expensive, is what we call read access geo-redundant storage. What that means is not only are we replicating our data across multiple regions, our applications are able to read data from those storage accounts at both locations. What that means is if I'm replicating data between US West and US East, I could point users of my applications to the storage accounts at either location, and they can access the data from there. Any read operations would need to be sent back to the master copy of the data, but read operations are a lot faster that way. So it's important to understand, especially for the exam, these 4 levels of resilience. And it's also important to be able to understand the number of copies of our data that are maintained for us. So for example, with locally resilient storage, we have 3 copies of our data. In zone resilient storage, again, we have 3 copies of our data, but they're spread out across different data center buildings, but still within the same geographical region. So within UK North, there are 3 data center buildings. Now data would be spread out amongst those 3 buildings. With geo-replication, it becomes more expensive, but we do move up to 6 copies of our data. So we have 3 copies of our data in, say, the UK South region, then we then have another 3 copies of that data in the UK West region. And when we move up to read access geo-redundant storage, we still have 6 copies of that data. So the idea is we're getting a lot of resilience for our money here. We get a lot of copies of our data, and we're still able to control the geographical spread of where our data goes to. When we configure our storage, we choose a primary location for it based on an Azure data center. Each Azure data center has a partner within the same geographical region that we can choose to host our data, the replicas of our data on. We can, if we want, replicate data to another region elsewhere in the world as well, if we don't have to worry about particular data sovereignty issues. So the whole idea here is that the data that our organization owns can be kept very safe. We've got a whole bunch of fault tolerance built into this. One of the few downsides, though, to Azure Storage is that when you create the storage subscription, you've got to be able to answer those 4 questions of location, performance, the account type, and the replication model when you create it. you can't go back and retrospectively change those settings. So you still need to do some design work to decide where it's going to be hosted, what performance level you need, and the kind of replication operations that are going to go on in there. So very quickly you see that there's still a need for architects and systems engineers in the cloud world. There are still design decisions that need to be made. There will still be change projects that come along where, say, maybe our storage requirements have changed and we need to create a new storage account and migrate data from one to the other because of the limits of Azure. But it's important to bear that in mind. There are limits to this platform, there are restrictions to this platform, and that's the space that we as DXC employees will most often live in. This is where we'll provide that value to our customers. Here's another example of a slide that you've probably already seen before. These are the 3 hosting methods. Now, I'm not going to go through every single bullet point here. The idea of a public cloud facility is where you take an offering like Azure, like Amazon's AWS or Google, and you run your workloads from that public cloud data center. The public cloud service, it's owned and operated by somebody else. It's there for you. You're just deploying your applications or your servers in there. And they're hosted out to people who access them generally over the public internet. The idea there is you're not constrained about scalability because it's Microsoft or Amazon or Google's job to make sure that whatever capacity you need there are met. One of the big benefits of that as well is lower IT overheads, and that comes from 2 places. One is Microsoft, Amazon, and Google have invested huge amounts of money in automation and orchestration to make this stuff happen quickly, so they require fewer engineers to run this stuff. But also as well, they're buying the hardware in scale, so they're getting it cheaper, and they're buying the hardware in bulk and effectively reselling it to you on a pay-by-month basis. The next model to discuss is private cloud. And this is probably the model that we're most familiar with. We actually have a private cloud as a service offering that we still sell within DXC, and it's ideal for a lot of customers. The idea is that we build and construct a data center, we put racks, servers, storage, network in there. That would just be a data center. What turns a traditional data center, though, into a private cloud is the fact that it's just one customer's workloads that run in there, and there should be virtualization technologies and data center automation technologies in there as well. So we get some of the benefits of automation, a lot of the benefits of management, but we've still got a lot of the benefits of security because it's our building. We own the building end to end. I used to do a lot of work in the Middle East in the very early days of Azure. So for example, the Bank of Israel, which is a financial regulatory body in Israel, says that Israeli banks must hold the physical keys to any data center where they store data. And for years, that's kept them in this world of having to stay on a private cloud. So there are still some circumstances where people need to own and operate their own data. Okay, it costs more money. You have to come up with big chunks of capital to make these things happen. People have a tradition of underutilizing the resources they've got. And what that means is they'll create a whole bunch of virtual machines with way more memory and way more CPU resource than they're ever actually going to need because of the way they're designing these workloads. But you get that huge level of control. So it doesn't take a genius to work out that a third way of doing things is probably what most organizations are going to need. And that's where hybrid cloud comes in. Hybrid cloud is where we take a public cloud offering like Azure or AWS, and we take our private cloud or our on-premises data center, we connect the networks together, we implement a hybrid directory service, so where we can authenticate consistently across the two, and then we have management tools that allow us to be able to choose, are we going to run our servers in the public cloud or the private cloud? And we can potentially move between one and the other. This idea of a hybrid cloud gives us a huge amount of flexibility. It also gives us the ability to change as well. So if we all of a sudden one of our workloads gets reclassified as, well, it used to be confidential, now it's restricted, we could then choose to move that virtual machine from Azure back to our on-prem data center. A lot of organizations are still going to have workloads that shouldn't run from the public cloud. Either the data assets that are contained within there shouldn't really be exposed to somebody else's data center because of governance regions, or maybe those workloads just need to be physically close to the employees that are going to work with them. Cloud platforms like Azure have some limitations as well. So, for example, DHCP is not a service you could run from Azure. One would argue as well that it makes sense to always maintain at least 2 domain controllers in each building. So not every single workload is capable of running to Azure. What this means is there's a lot of startup companies coming out now that are growing very quickly because they've got access to the public cloud. They can deploy infrastructure in there and deploy stuff really quickly and grow. I know one company near where I live in the northeast of England. They write gaming software for large online casinos, and they've grown in the last 5 years from 3 employees to 250 employees, and their turnover has grown from like 1 million a year to about 30 or 40 million a year in that time as well. They've grown because they've put everything in the public cloud. It's made them really agile. They haven't put lots of cost in up front to do that. So a lot of companies that are starting today will look at a public cloud only model. So they get their email from Office 365, the collaboration from 365 or Gmail or Blue Jeans for their collaboration software. Where they host servers, they'll probably put them in some place like Azure or Amazon. Private cloud only is something that's dying off, but large organizations are not throwing away their data centers. If they've outsourced their data center to somebody else to run them, or they've put their stuff in somebody else's private cloud that's being hosted for them, they're just as likely to move to a hybrid cloud model anyway. What we're seeing in the space we generally work at here at DXC is most organizations, like it or not, are probably already running in a hybrid cloud environment, where they've at least got some dependency on some services that are being run either on infrastructure as a service, platform as a service, or software as a service. I used to have this conversation with CEOs and CFOs and CIOs, and it was about, well, did you know your organization is already running hybrid cloud? And they would say, nonsense, we've put nothing in Azure, we've put nothing in Amazon. I'd say, okay, do any of your users browse the internet? Well, yeah, of course they do. Right, well, you're dependent upon services that are delivered through a public cloud provider. Your ISP provides you with internet access. They're probably using apps that are out there on the public internet. Okay, but that's not mission critical. Okay, what about DNS? Name resolution. Do you use public DNS name resolution when you're trying to access external resources? Time services, offsite backups, collaboration tools, Office 365. The reality is, for the vast majority of organizations, is probably about 99.5% of organizations have been running a hybrid cloud for many years. So they've been dependent upon external services provided by public providers. They just haven't realized that. So actually that move to hybrid cloud from private cloud is not as gaping a gap as it used to seem to be, because people are already really doing this. And as well, find organizations as well are just much more willing to spend money using OPEX, where they just have to spend a small amount every month than having to go away and find large chunks of capital to build data centers or to refresh server hardware. The hybrid cloud is pretty much going to be the norm for large organizations. Newer, smaller organizations, will probably continue to use public cloud. And private cloud might remain the purveying of certain very specialist banks, defense organizations. But to put that into perspective, the US Department of Defense has built their own Azure regional facility. And they've got their own place in Azure where they can host stuff and it's dedicated to them. So even those high security challenges like the US Department of Defense and the US military and the US government, the use of private cloud in there is now increasingly being challenged by the financial decision makers. Now here in the UK, if you want to build an application, you have to be able to demonstrate to the security regulators why you haven't chosen the cloud platform to run that and why you've got to have the investment to buy a load of capital to do this stuff. Why won't it work in the public cloud before you're allowed to even consider private cloud? So, we have talked a lot about Azure. Now it's time for me to show you some stuff in Azure. The nice thing about Azure is when we access it through, normally through the portal. So that's what I'm going to show you here. The URL for Azure is portal.azure.com. Yeah. What that means is that subscription is where the bill for that resource is going to go to. Sorry, some reason it's taken into the database bill there. One of the things it's possible to do within Azure is to configure policies. As I've said before, this portal is incredibly powerful. So I could come along and create resources in here. So Azure policies will prevent me from doing certain things. So that subscription where I've tried to create the virtual machine before is probably just doesn't have the rights to create. There's probably policy preventing me from creating virtual machines in there. So we've told Azure where the build needs to go to. Now what I need to do is organize the objects I'm going to create and keep them in what we call a resource group. When I create a virtual machine, there's going to be quite a few resources that go alongside the virtual machine, like my virtual hard drives, the IP addresses that it uses, its network cards, and so forth. So it makes sense to logically group those resources together. That's what we use a resource group for. So I've just created a new resource group called test to keep all those things in there. Now, obviously, I need to give the virtual machine a name, and that serves two purposes. Firstly, to identify the virtual machine inside Azure, but also to identify the operating system. So the virtual machine name I provide here will be put into the build of Windows to make sure that's the computer name. So I'm going to call this I'm following a very simple naming convention here. That's the organization name. Sorry. So I have a unique identifier at the end with these numbers. I'm using the words VM to indicate this is a virtual machine. TST, that indicates that this is a test machine. And DCC is the name of the organization it's going to be created in. Good practice is not to get too hung up around the names of our resources, just to have a very simple naming convention. Because if we're trying to go searching for something like, let's find all the Windows virtual machines or all the ones in the production environment, we can use resource tags for that. A lot of people will overthink their naming convention. The trick is to keep it very simple. I then need to tell Azure, well, where do I physically want these resources deployed to? So I'm going to choose to deploy this in East US. Azure has a couple of options that are available to me for high availability for a virtual machine. What I can do, I can just deploy the virtual machine as it is, as a single virtual machine using managed disks, and Microsoft will give me a 99.9% SLA on that virtual machine. What I could do, I could deploy two virtual machines into what we call two or more virtual machines into what we call an availability zone. That will make the virtual machine more expensive because I need two VMs to do that. They'll add a load balancer to it. And what they'll do is they'll separate out those two virtual machines across two data center buildings for me. So my application would survive the loss of an individual data center. Or I could deploy two virtual machines to an availability set where, again, it would be load balanced and the two VMs would be kept on different hardware in the same Azure facility. So an availability zone would give me 99.9% availability SLA from Microsoft. and availability set would give me a 99.95% SLA. As you can see, as you go up through those options, the costs go up, and the amount of high availability you get increases with that. When I first started working with Azure, this was something that really surprised me. Microsoft is allowing us to deploy Linux workloads in here. Microsoft, because of Azure, is now the largest contributor of requests for change to the Linux platform. Microsoft have hugely got behind Linux, and there's really appreciation within Microsoft that Red Hat, SUSE, and Ubuntu have their place in enterprise space. The whole idea there is there are certain workloads, there are certain use cases for servers where Linux is just better, either because it's lighter, or there are particular workloads that will only run on Linux, or maybe we need to move an application from one platform to another. So we can choose the operating system that we want to deploy this workload onto. Now I'm actually going to take Windows Server 2016 here as my operating system. Now what I can do here, I can come along and I can look at a repository of my own private images that I've created, or I can choose some customized images that have been made available to the general public in there. I'm just going to go with the bog standard installation of Windows Server 2016. I have to be able to come along and tell it how big to make this virtual machine. You can see here we have the idea of VM sizes, offerings, families. And what happens here is basically we're buying a size of hardware. Now this can be nice and cheap. I can have a virtual machine with one CPU and half a gig of RAM for just £5 a month or €5 per month. Or I can go up to something significantly larger where I have 4 CPUs, 14 gigs of RAM, 16 data disks for about €300 a month. There's a whole range of machine sizes. And this view, when you first go in there, these filters are applied to bring down the list. So what I'm going to do is I'm going to come along and remove all these filters just to give you an idea of the number of different sizes of VM that are available. And you can see the cost here will differ significantly based on the size of hardware I'm buying. It's important to remember when you're buying an Azure virtual machine, you're not just paying for the hardware it's running on, you're also paying for the Windows Server license. And if there's anything like BizTalk or SQL Server built into the image, you're also paying for those licenses in there as well, potentially. Now, if I scroll down here, you'll see some quite interesting numbers. As the machines get more expensive. Now this list is still refreshing. That's how many offerings there are in here. But there's a BizTalk server offering that's €19,000 per month, even larger than these. To give you an idea of the families of virtual machines, these are quite important. So if I organize this list by family, we've got a couple of different types. We've got the idea of compute optimized. What that means is it's heavy on servers compared to the amount of memory you get. Look a bit further down, we've got general purpose machines. They have a fairly even balance of memory to CPUs. There's all sorts of different sizes available in there. We've got GPU virtual machines. So you could buy a virtual machine that's got an NVIDIA graphics processor in there. That's quite important because you might be deploying something that's quite graphics intensive, like a VDI infrastructure. You could be building that on Azure virtual machines, or you could be producing a workstation that's going to do some sort of data science and heavy computational maths. And as it turns out, the CPUs that NVIDIA make for their graphics cards are just highly more scalable and highly optimized for complex mathematical operations. So buying a virtual machine with a GPU in it adds some cost, but it gives you a lot of different scenarios for special workloads. So when you're coming in here, you need to be able to choose the family of virtual machine size you want. The amount of capacity you get, is one thing, but what workloads that VM size is optimized for is quite important as well. So what I'm going to do, I'm going to be a real cheapskate here, and I'm going to deploy the cheapest possible virtual machine. If If you look here at this standard F1 virtual machine here, it's got one CPU and it's got 2 gigs of RAM. Yeah. If I'm going to run a production Windows server, you might be questioning, what are you going to be able to do with just 2 gigabytes of memory? Something that's really important to bear in mind here, right? Microsoft for years was in competition with Linux. And one of the areas where Linux was far superior to Windows was just in how efficient and light the Linux operating system was in terms of its hardware footprint it consumed. Microsoft had done something here very clever to level the playing field. The amount of memory capacity you're buying here from Azure is the amount of memory capacity that's available to applications running. When you buy a VM with 2 gigabytes of memory, there's an additional 1.5 gigabytes of memory given to it for the operating system components to run in. You know that basic footprint that the OS needs to run on a Windows server? That's added into there. They also add that footprint into a Linux machine as well. It's a smaller footprint the operating system needs. So they separate out the memory usage from the core operating system from your applications. That's done at a hardware virtualization level. You don't have to worry about that. But what that means is when you're buying these virtual machines, this is the amount of memory that's available to run applications on there. So having a VM with 2 gigs of memory, in fact having a virtual machine with half a gig of memory, is still a worthwhile endeavor because maybe my application only needs half a gig of memory. The operating system isn't taken into account in that amount of memory. So I'm going to choose a general purpose A0 virtual machine. It's got one CPU and 1/4 of a gig of memory available for applications. Notice there are also some limitations to the number of data disks I can add in there. So again, when I'm provisioning these things, I need to be aware of those limitations and I need to make the right decision at the outset. When creating a virtual machine, I also need to give some storage to it as well. By default, Azure will give a virtual machine an operating system drive and a temporary drive. I could, if I wanted, come in here and add an additional disk, which is blank, or I can add an existing snapshot of a hard drive, or I could upload a drive image and attach that to the machine as well. I also need to run my virtual machine with a connection to a virtual network. Otherwise, it won't be able to do anything for me. But here, Azure has seen that I don't have a virtual network already, so it's going to create one for me. And here it's giving me some options around how I manage this virtual machine. I'm going to turn on boot diagnostics just in case something goes wrong with the build or the machine or the boot up of it. I can choose to enable guest diagnostics, which will allow Azure to look at and to log the events in my Windows system logs in there. And what I can do is I can create a storage account in which to keep that. I'll switch that off for now. This is really powerful here, auto shutdown. If I'm making a machine that's not for production use, let's suppose it's going to be used by software developers to test an application, why would I want to pay for that server to be available 24/7 if the people who use it go home at 5:30 p.m.? What I can do here is put in an auto shutdown rule that'll shut this VM down every day at 5:30. So, okay, the developers need to come in and start that machine up on a morning. I could create a script to make that happen automatically though. But what's going to happen now is when it gets to 3:30, this is now going to send me an email 15 minutes before the machine's due to shut down. And it's going to say to me, I'm going to shut this VM down now automatically. You can reply back by saying no to this email to prevent that from happening. By making that one small simple change, that means this virtual machine now only needs to be on 40 hours per week, as opposed to the 160 hours per week that it would be on if it was left on all the time. This is an example of one of the many ways you can reduce the cost of running infrastructures in Azure. Now, granted, not all of your servers you're going to be able to shut down outside of business hours. But if you've got an application where you've got multiple servers, and maybe you've got 4 servers in there and it's load balanced to cope with peak capacity, if at weekends or in evenings you only need 1 or 2, you can shut down 2 of them and reduce your operating cost. With virtual machines, you only pay for what you use. If these machines aren't up and running, they're in a state called deprovisioned. And you're not paying for stuff that isn't running. And this is nice and powerful. I'm going to enable the machine to be backed up, and I'm going to just put the backup configuration in here. All I've got to do is tell it which vault, which storage area will the backup images be kept in, and I'm just going to say, going to create a backup resource group to structure those backup objects. We keep the backup objects separate from the virtual machine objects. And then we have a daily policy. The default is it'll back the virtual machine up once per day and keep the snapshots for 90 days for us. And then finally, what I can do in here, I can add in management agents I want to add into there. I can add extensions in at the BIOS level as well if I want. I don't need to do that. What I do want to do though is add some tags to this virtual machine. So I'm going to create a tag called cost center. I'm going to set the cost center tag for this machine to have a value of sales. What I'm saying there is this machine is for the sales department. They should get the bill for this. So I can use this tag to decide how the bill gets broken up. I'm going to have a business owner as well. And this is just free text in here. And I'm going to say, I'm the business owner. So what I can do if I want to find out, if I want to restart this machine or I want to shut this machine down as an Azure administrator, I can look at the tags now and I can see who's the person I need to contact within the business to make a decision about these things. I'm also going to apply a technical owner. Into this as well. So if somebody's the main techie that's responsible for this service, he can do that. Some examples of other tags that I frequently use is the service level agreement. That needs to be in place for it. The environment, so let's say this is for staging. Actually, no, this one's for test, isn't it? I suppose I also want to say region. So this is for North US. I suppose I want to keep information about region. Server role. So let's suppose this virtual machine is going to be a domain controller. So what we're able to do is document the service that's going to run. We're able to document the service that we're providing in here. One day we'll learn to spell correctly. So the idea is with these tags, we basically are creating the metaphorical equivalent of a sticky note that goes on side of a physical box. So we can just take a look at the tags of a resource and see who's responsible for it, where the bill should go, how available it needs to be, what environment it's for. Creating these tags is really powerful because not only can your administrators just look at these tags and see what the box is and what it needs to do and who it works for, but they can also use these tags to target automation jobs. I can create a tag called auto shutdown 1730, yeah, and I'll set this value here to be true. I'll create another one which is auto shutdown 1930. I'll set that to be false. What I can do here is I can create a script that targets every virtual machine that has the tag auto shutdown 1730 in it. Where the value of that is true, it'll force Azure can then send an automation script to that virtual machine to shut it down at that given time. We do something similar with auto startup 0800 and set that to be true. Now all I need to do is write a runbook that starts up every virtual machine where the auto startup tag value is set to be true. That's the power you get with tagging. Not only are you documenting operationally what's happening with this resource, but you're also able to configure and target automation jobs as well. And then finally, it's just going to give us a list of the configuration. I can see here that I failed to fill in one box on this. I'll just have a look down through here and see if I come back to management. Turn that off, and that will resolve that issue because I hadn't configured a storage account for it. Over in basics, I'd missed some information out. So I hadn't scrolled down correctly here. So what I need to do is give the local administrator account on this computer a name. So word-wise, Azure won't let you use the name admin or administrator or root when you're creating a local administrator account. It's too easy to guess. So this is one I tend to use in test environments. And then I need to give the virtual machine a password for that local account. It needs to be long, it needs to be complex, because it's a local admin account. It's going to be very powerful. So it's enforcing not only have I entered the right password, but also I've entered one that's suitably complex enough. What I can do as well at the same time is create a public IP address on this machine. I don't have to create a public IP address on my machine. Most servers you create should not have a public IP address unless it's hosting a website. But what I can do here is I can enable a connection to this box publicly to remote desktop protocol, so I can RDP to this box from anywhere. Here's another example of an option here where we can bring down the cost of what we're hosting for people. If this is a pre-production machine, we can use an MSDN or an evaluation license for this. By saying we already have a license for it, we're reducing our cost by 49%. Maybe the customer has got an enterprise agreement on-prem with Windows Server licensing that they can use, bring your own licensing or hybrid benefit. So they don't have to pay for that license twice. 50% of the costs we're running at on Azure VMs are for the licenses. If I say no over here, it's going to basically just tell me that I can't do that. But if I say yes, I can say what type of license I've got, and I confirm. I'm just saying here that I acknowledge that I'm underpaying because I've already got a license. Come along back now. That gives me everything I need to do to create that virtual machine. I can see here it's going to cost me about €1.50 per hour that it's running. Just going to evaluate, make sure everything's correct. So the validation's passed. Here we go. We can create the virtual machine. What's really powerful there is the validation that we've put the right configuration in there. We can't make mistakes with this and build something that's not going to work. We can also use Azure policies to implement our own organization's policies in there as well. So if we say that when we create an object, it has to follow our naming convention, or we can only deploy it to regions where we're allowed to, that will keep, we can put policies in place to control what people who have access to this console can do. There's not building that virtual machine for us. It shouldn't take too long for it to do that. So what's happening in the background, this screen here on Azure is telling us what's happening with our deployment job. Up here, we've got some buttons here in the Azure portal. This one here is the alerts and notifications blade. If I click on that, I can see here I've got a deployment job that's running. Now it still takes a couple of minutes to build a server. It'll create the virtual machine and attach the storage and the network pretty much instantaneously. But because it's got to apply a build image to that virtual machine, and the operating system has to answer some questions to the sysprep routine on that machine, it just takes a couple of minutes for that to run. It's important to remember not every operation happens immediately, so we need to keep an eye on this tab here to make sure when things are completed, they've completed successfully. If we want to have a look and see what's been happening in our environment, yeah, we can use this filtering tab to move between different environments. As you can see here, I've got rights in a couple of different environments. I can switch from one customer's environment to another here because my account has been added into each of those. We'll talk about this in a lot more depth later on in this course in Module 3. This is the Azure Cloud Shell. Let's suppose I'm more of a developer and I'm very familiar with the power of scripting. What I can do is I can come in here and I can correct that, and I can send PowerShell through the Azure portal to configure things. So I can write a PowerShell commandlet that will automatically create the virtual machine with whatever parameters it needs to answer these questions to build it. I can also use the Azure command line interface to send bash commands into here. So this is quite important for us. I'll just give that a few minutes to build out and create that storage for us and come back to it. So we can see here our virtual machine, it's created all the underpinning jobs for us. It's created the backup policy for us. It's created the public IP address we needed for it. It's created a network security group to lock down what can access that public internet connection and just restrict it to remote desktop traffic. It's created the virtual network the VM's attached to. It's created a network card for it. Now it's just creating the virtual machine for us and populating the build. So in a few minutes, that updating logo will turn into a complete one. Perhaps the most important part of Azure, as well as paying for the operating system, and paying for the hardware and the licenses, we're also buying some level of support with Azure as well. So I can click that help button here and come along and see the documentation for all the Azure offerings. I can see what support cases have been created recently. What I can also do is come along, create a new support request. Suppose I've got an issue with a technical issue, and let's suppose it's to this subscription, and in here having problems with a virtual machine running Windows, complete failure after VM integration, problem type, my guest operating system suppose and restarts. First of all, Azure will help us diagnose this. They'll give us some steps to go through and just follow through to troubleshoot this ourselves. But that's useful. What we really want is to be able to create a support case directly with Microsoft for them to come in and fix this stuff for us. This is the real power of Azure, is that support's built into it as well. So it'll take the information we provided in the basic screen and it'll create the support request for us. It'll send that off. It's asking us to provide a little bit more information. So it's on standard storage. We're running server 2016. A little bit more information there. When did the problem start? Tuesday. If I want to attach a file to it with some logs in, I can do that and share the diagnostic information with Microsoft, and it will give them access temporarily to the storage account in Azure where all my logs live. I could choose, right, this is a critical issue for me. That means they've got to contact me by phone. If I go for moderate, then they can email me, so I can choose how I want them to contact me. And you provide your information in here. Then you just go hit review and create, and that's logged the support case with Azure support. I'm not going to bother creating a support request now, but what I will do is come back to my virtual machine deployment and see how that's going. It's not unusual for a VM deployment to take up to 10 minutes just because the image itself needs to be populated. One of the things I can do when I've created an object is I can create a template from what I've just built. So we call it ARM template. So whatever I've built here, I can download the template from it. I can modify it, modify the contents in the JavaScript file that contains all the settings. Then I can choose to redeploy that template elsewhere. So I can build this VM once, then redeploy it elsewhere with differences using that ARM template. It's quite powerful. We'll see that in one of the later modules. If I look down here at the template, this will give you an idea of what that template would look like. Now I know this is code. The fundamentals exam, you don't need to be able to go in and work with templates. But you can see here, ultimately what we're doing with this template is there's a standard defined by Azure that says how ARM templates should be configured. And you can see here what we're doing is we're just bringing in various values into the file. So for example, the name of the network interface, the name of the security group that locks it down. These are all the questions that Azure needs to be able to answer in order to create a virtual machine. And down here you can see these are the tags that we apply to that virtual machine. So the template file that's created, this is what's actually taken and consumed by Azure. This portal is just a graphical user interface that allows us to build these template files and send them to Azure. So I could download that template file and work with it. Let's suppose I wanted to create a virtual machine by just running a command from the command line interface. This would be the script I need to run to create that, and it's populated all of the variables in there for me to give me the same configuration. I can copy that text out, paste it in the command line interface, I can edit it as I want, then run it, and that will give me the same virtual machine. Here's the PowerShell command to create that virtual machine. So I don't need to be an expert in PowerShell or the command line interface to be able to build these resources. I can build the first one out in the portal. That will give me the template or the scripts to run to be able to create one of these things. Here is the .NET Framework code. So we can write code in a .NET Framework application and have it send commands to Azure to build things. That means your applications can now build their own infrastructure. That's quite powerful. So this would be the .NET commands we would need to send from one application to another to have this application build out that virtual machine. And this is the Ruby syntax if we're going to use the Ruby scripting language to do that. This input screen here just gives us a list of all the questions that we've had to answer and the values that we've put in there. And the outputs, this just summarizes the settings that are put into the deployment. Now you can see here we don't have any outputs from this deployment because the job is still running. When the job runs, when it completes, the sort of outputs that we'd see in there is that yes, it's been created, it's completed, and here's the values it's populated into Azure for us. One of the things to call out to you guys over here is the Azure Learn website. This is where you'll see a whole bunch of additional labs being hosted. A lot of the documentation and steps I'm going to send out for us to do some of the lab exercises will involve us going in here and doing some of the hands-on labs from here. This is a really good website to bookmark for yourselves. This is docs.microsoft.com/learn, or you just Google Microsoft Learn and it'll bring you to this website. And what it'll do is it'll give you a learning path. If you wanted to learn something specific in Azure, you can follow these work plans and you can run through it. And it'll give you labs, and it'll give you video recordings. There's also links here as well to the certifications as well. Really useful to have. So in a couple of minutes, this virtual machine will finish building. And what I'll do when it finishes, I'll RDP onto the server, and you guys can see it up and running. So what I'm going to do now, I'm going to switch back to the presentation mode. And we're going to cover the next slide. The next part of Azure, so the next part of the Azure Fundamentals exam is probably the most significant part of it. And this is about gaining an understanding of what are the sort of things you can build and host on Azure. So there are some architectural components we need to understand that describe the structure of Azure. There are some core products that are available that we can take. We also call them resources in Azure that we can build. So a virtual machine is a resource, an application service is a resource. So we'll discuss what some of those products are. When we get into the labs, we'll actually get some hands-on experience of building those things as well. There are also some pre-built solutions available in Azure. There are some really advanced workload types like Internet of Things, big data, machine learning, data science, artificial intelligence, and serverless computing, where all the building blocks you need are already available. All you've got to do is put your logic into them. So I'll give you a rundown of some of the key areas that are available there as well. And then finally, we'll close out this module in today's lesson by taking a look at the Azure management tools that are available. And that is the different ways we can come in and work with Azure resources in addition to the portal. Before we go much further with Azure, it's really important that everybody has a solid understanding of what Azure physically looks like. These are the Azure regions. So Azure is available in 140 countries around the world. It's hosted from 54 different regions. So you can see there are a chain of data centers all around the world where there is a Microsoft data center where you can provision Azure workloads into. Each one of these individual regions has a regional pair. So for example, there's a relationship between West US 2 and West US 1, which means if we do zone redundant storage, our data gets replicated between those two. The idea is because I've got two data centers in a region, I can fail over my workloads from one data center to the other and not leave a geographical area. Now in the US, there's several regions available because of the large distances available. So, that network latency could have an impact there. Here in the UK, for example, we have UK West and UK South. They're about 150 miles apart from one another. So the idea is I can fail over from one data center to the other and survive the loss of a region. Each one of these regions each one of these regions comprises of multiple buildings called facilities. Each one of those facilities is a data center building in its own right. Let's think about what goes into a data center building. We've got to feed power, air conditioning, and network connectivity into there, to the public internet and any private circuits that connect into there. Each one of those buildings has multiple sources of power, multiple sources of air conditioning, and multiple internet connections coming in to give us, high availability. Inside a regional facility, we separate out our infrastructure into what we call availability zones. So the idea is that an availability zone is a completely independent set of services. So for example, I have one set of power supply, one set of racks, one set of servers, one set of storage appliances, one set of internet connections, one set of network cabling for this availability zone. And the servers that live over here in this other availability zone are completely independent of these ones over here. So there's no single point of failure between any of these three availability zones, meaning anything can go bang in there and stop working and it'll still be available in the alternative availability zones. When we come along and position our virtual machines or our PaaS offerings or our storage in Azure, when we use things like availability zones, we're choosing to position our virtual machines on different availability zones within the same region. So these are usually separate buildings as well with high-speed connections between them. So I can have domain controller 1 running over here, domain controller 2 running in availability zone 2, and domain controller 3 running over here in availability zone 3. That means I could lose an entire availability zone and the other two domain controllers wouldn't be affected by that at all. If I choose to deploy my virtual machines in an availability zone which follows this architecture, I'm basically deploying them across 2 or more of these regions. Microsoft will then give me a 99.9% SLA on my virtual machine being up and available. Pretty powerful. So think about it. A region comprises of multiple facilities. Each facility is its own availability zone with its own infrastructure of racks, networking, storage appliances, internet connectivity, air conditioning, and power. Inside a region, there's a regional pair of data centers. So each region comprises of multiple facilities or buildings. Every region has a pair. So in every sovereign territory like the United Kingdom, there are 2 regions, UK South and UK West. In Europe, there's Europe North and Europe West. In America, there's America Central, East, West as well. So you can still have resiliency and not have your data or services leave a geographical area. One of the key building blocks of Azure governance is resource groups. So as you saw when I created that virtual machine, I had to create a resource group object. The idea around resource groups is they allow me to group together the component resources that comprise of the service. If I was creating some domain controllers in Azure, I would create one resource group called domain controllers. I would add all the virtual machines, all the virtual network cards, all of the virtual hard drives and IP addresses into that resource group. And that way I can centrally script and control access to those resources. As you see up here, subscriptions, they're just a way of paying for things. Every resource group and every resource has a relationship with a subscription that pays for things. Then we have this concept of management groups, which is about allowing resources to have access to multiple subscriptions and multiple resource groups. Azure Resource Manager, this is our way of controlling what happens within Azure. And there are 4 main ways that we send configuration into Azure. The first we've already seen in detail, where we connect to the Azure portal website and we work with the graphical user interface to send configurations in there. There's also the Azure command line interface and Azure PowerShell. So what happens is Azure has an API that over the public internet can receive commands sent to it through the command line interface or through PowerShell. Now those connections do need to be authenticated. We need to authenticate and they are encrypted, so that is quite a secure mechanism there. So I can install the command line interface on my workstation. I can install PowerShell and the relevant modules on my workstation and remotely configure Azure. Or I can work with either of those command line interfaces through the Azure portal using that little button I showed you at the top. The other mechanism that Azure Resource Manager can take commands through is directly through the APIs. So I can write my own applications that send messages through Azure's APIs, and I can send code and instructions to Azure that way. So that instruction might be, create me an Azure AD user account, reset this user's password, create a virtual machine, shut down a virtual machine or stop a virtual machine. And this resource manager engine is basically an orchestration engine that makes things happen within Azure. It's a modeling language that describes what all of these resources are. Whenever we deploy anything through Azure, either in the portal or the command line interface, we're populating a template, and that template gets deployed into Azure, and that will create the various resources that we want. So anything we deploy in Azure, we can download the template for it. We can modify that and we can reuse that to consistently deploy the same resources elsewhere. Azure has some core products. So if you think about the need to be able to move servers out of a physical data center or move applications out of a physical data center, these are the kind of building blocks that we build our Azure solutions on. So for example, within compute, we've got the ability to create virtual machines. We can create virtual machine scale sets. So we create one virtual machine image, and then we load balance it. And as that machine gets busier, it creates replicas of that virtual machine to allow it to scale out. We can also host platform as a service apps where our developers are just given a runtime environment that meets their specifications that they can publish their apps into. They don't have to worry about the underlying operating system. They don't have to worry about a server or anything like that. They just put their code in there and it runs. Then we've got two options for what we call serverless computing. So with the Azure App Service, there is a virtual machine that sits underneath those runtime environments, but nobody has any access to them. With Azure Functions and Azure Kubernetes, there is no connection to whatever operating system is being run underneath this stuff. They're just discrete areas of code or containers where that code runs. So it's serverless computing. We can create a whole bunch of objects within networking to allow connectivity between virtual machines, the public internet. We can create load balancers. We can have VPN connections that connect us to on-premise networks or to other Azure clouds or even AWS if we want. We can create application gateways which provide stateful inspection of traffic and like an application firewall to front-end our applications. We've got offerings like the content delivery networks that allow us to cache content and distribute content globally around the world. What's really cool about this stuff is I used to work for organizations that they would maybe have 10 employees, but they needed a website to be highly available. How do you scale up the economics of a 10 employee organization to having to have maybe like a 4-node server array and a network load balancer? It just doesn't add up. Because you can now just deploy a load balancer in Azure and you don't have to buy your own appliance for it, the platform's doing this work for you, you can use these more advanced networking infrastructures and you only pay for what you use. That entry-level cost goes away. Storage, we've got archive storage, which is nice and cheap. It takes a bit longer to access the data on it, but you pay for each time you read it rather than how much information you've got there. Then we've got file, disk, and blob storage accounts we can use for our apps and our servers to keep data in. There's a whole bunch of database as a service offerings. So pretty much any one of the major database platforms like SQL Server, Cosmos database, MySQL, there are platform as a service offerings that will just create a database instance for you, and you don't have to care about the operating system that's run underneath that. You just engineer the database, and Azure connects to it. Azure allows your users to connect to it through a network. The Azure Marketplace, I'll just quickly show us the Marketplace again to illustrate this. When I come along to create a resource, I go into the Marketplace. So I can browse by all these categories of resources I could buy in Azure. I could buy virtual machines running Windows, Linux, and Ubuntu. I could buy an IoT hub. I could buy a load balancer, or I could buy an entire solution. So the idea is I may just be buying an individual building block, or I may be buying several building blocks together that allow us to do things. And there's also different offerings in here, like software as a service offerings, where you can create your own instance of Bing Maps or a Barracuda web application firewall as a service. There's DevOps offerings in here for us to be able to create the management tools we need to be able to run things. Create virtual machines. Why create a virtual machine if all we want to run is an app? We can have containers in here. There's a whole bunch of things I can buy in size and deploy from here. And this is what the Marketplace is all about. All these offerings have been reviewed by Microsoft to make sure they're in and they're supportable and that they work. So you can buy these things and consume these things with confidence. That's the Azure Marketplace. In some cases, when you're shopping through the marketplace, you can also buy the licensing for the software running in the virtual machine. So for example, if I was to go and buy a SQL server through the marketplace, I'd be getting the SQL licensing as part of that. Under some circumstances, third parties put their offerings in there and they make them available as a virtual appliance or an image. In some cases, you may need to buy additional licenses directly from the third party. In some cases, the licenses are included. One of the big benefits of Azure is dual data center fault tolerance. We talked before about multiple data center regions. We have a primary and a secondary region. So for example, in my country, this is UK West and this is UK South. What I can do is I can deploy infrastructure into both regions. Then I can use a tool like Azure Site Recovery Manager or SQL Server Always On to replicate my data between those two regions. Then I have an external load balancer called Traffic Manager and individual network load balancers that allow me to. So Traffic Manager will shape which data center my traffic goes into. Traffic Manager will look at the health of these VMs over here or this entire region, and if this data center goes bad, it'll prefer to send workload across to the secondary region. Now to do that, in the old world, I was probably spending a minimum of £5 million a year to get the kind of infrastructure to support that. I needed 2 data center buildings, I needed a dark fiber network between the two, I needed a whole bunch of specialist management technologies and operations people. Now as a small company, with just one server, I can do this now on Azure. I don't pay anything for the load balancers. Azure Traffic Manager costs me very little indeed. I just pay for my virtual machine running here in this region, and I can replicate it across to the second region. Azure is a big game changer because it levels the playing field. Even smaller organizations can have dual data center fault tolerance by removing this down. Disaster recovery. If we've got 2 data centers where we can store resources, we need some mechanism of performing a failover and a failback from those locations. Azure has a service built into it called Site Recovery Manager, and what that will do is handle replicating our virtual machines from one Azure region to another. We can also do Azure Disaster Recovery from an on-prem implementation of VMware or Hyper-V and replicate those virtual machines into Azure. Site Recovery Manager takes care of replicating the virtual machines for us. It also takes care of the coordination and orchestration of failing over these machines. If I'm doing a planned failover, SRM will gracefully shut these machines down. As they shut down, they'll replicate to the latest version across the cloud. Then the machines will shut down here and they'll start up over here. Then we have a failback operation, which does the same thing in reverse. People used to spend multi-millions pounds a year trying to get to that. You need to be a fairly sizable organization to get there. Now, as a 2-person startup with 1 or 2 servers, you can achieve that in Azure and not spend any more than $100 per month to get to that. This is just an illustration of how Azure scale sets work. The idea here with scale sets is we create a virtual machine and we load balance it. So the idea is if the amount of work that virtual machine needs to do increases, what we can do is we can have the scale set clone the image of that virtual machine and create another instance for it. And what it'll do is it'll automatically configure the balancer to scale this workload out. So I create my app, I deploy the image for it, I give the scale set some rules about when to scale or why to scale and when to scale back down again. And it can scale up to 1,000 instances of that virtual machine for me, just based on how much workload's going in. Obviously, you've got to put some very intelligent work and thought into the scaling rules for that, but the ability to scale up on demand is hugely, hugely powerful. One of the concepts that's vital for us to understand for the fundamentals exam is the difference between Capex and Opex. Capital expenditure is where you have to go out and find large, bulky chunks of cash to pay for something. So if you think about creating a data center, you'd need to spend a lot of capital to buy the building, to populate it with servers and racks and network appliances. Yeah, that means you've got to find that cash up front to do that. When organizations have money left over in their bank account, the last thing on the CFO's mind is fueling IT spend. If I've got 5 million in my company's bank account, I would much rather take those $5 million and use that to buy out my competition or invest in research and development or something that grows the business rather than having to use that capital to fund IT projects. Back in the days when I was an enterprise architect, I would go along and I would speak with CEOs, CIOs, and CFOs and tell them about, okay, well, we're gonna give you this new managed desktop. It's going to save you £2 million per year, and it's going to cost you £500,000 to do. I could be saving a company £5 million a year, yeah, but if they can't find the £500,000 it's going to cost them up front to build that solution, they haven't got the cost to do that. Trying to find Capex is a huge blocker for a lot of customers. Yeah, if you haven't got the capital to play with, doesn't matter what the return on investment is, you can't do that project unless you're going to go to the bank or raise capital somehow. And that's difficult in tough economic times. On-premise workloads tend to be driven by Capex. To buy the premises, buy the hardware, buy the network, you pay for it in one big chunk. Opex is easier for them to find with, smaller and paying for stuff on installments, yeah, paying for what you use as you use it, yeah. Businesses change what they need to be able to do, yeah. So being able to move to an Opex model is really good. The number of projects that have been rejected that I've worked on in the past, there are probably about 30 or 40 multi-million-dollar projects where we could have made massive savings for organizations that weren't possible purely and simply because the Capex required to buy the servers and the storage wasn't available. If we move to an OPEX model, yeah, the big financial outlay just disappears. That means our customers are able to take the solutions, we are more likely to be able to accept the solutions we want to build for them. They're more likely to be able to make better use of IT because that hurdle of trying to find the big bunch of capital up front is no longer there. If we can host the stuff on Azure, yeah, the amount of capital we need to find reduces drastically because we only pay for what we use and we only pay for it as we use it. There are 5 tools we need to be aware of for configuring Azure. Yeah, we've got the command line interface, the portal, the Azure PowerShell commandlets, Visual Studio, and the Azure APIs. All of those tools work through this layer called Resource Manager. So ARM, or Azure Resource Manager, is the language. It's a layer that allows us to create virtual resources on the physical infrastructure that Azure gives us to. So we have this idea of a hierarchy within Azure of an account or a tenant that has subscriptions that fund things, then resource groups that contain the individual building blocks of a given solution. All of that framework is defined by the Azure Resource Manager model. The ability to be able to use these 5 tools to send configuration into Azure is fronted by the Resource Manager services, which expose APIs that allow us to send commands into Azure remotely. And then finally, let's have a quick run through and just compare those different options for the portal. So for sending commands. The portal, it's a GUI. We've seen that. I can use it from any browser or run HTML5. I still have to authenticate to get in there. There's no point having something like Azure if any other idiot can come into your tenant, delete your virtual machines or your storage. So strong authentication and encryption of the connections are must-have for this, and that's all built into that. This is the Azure PowerShell commandlet. As you can see here, this is intended for automation and for people that are used to working with scripting languages. You get to a point in systems engineering where if you're proficient with scripting, you could be a lot faster doing things on scale and at mass using scripting languages like PowerShell. So we're sending commands through basically a terminal connection into the Azure portal here. PowerShell at the moment only runs on a Windows computer. We haven't really got an option for running PowerShell locally on a Mac, a Linux, or a Unix machine, although what you can do is you can use a web browser on a Mac or a Unix machine, connect to the Azure portal, and use the portal integrated command environment to do that. But we don't have a version of the PowerShell module that installs locally on those machines yet. I've seen a few exam questions come up lately to test around that. We also have the command line interface. One of the benefits about the command line interface is it uses the Bash and Perl scripting languages. So those are readily understood and used already within the Linux and Unix communities. That's a skill set that those systems administrators already have. Because it just runs through a command line interface, we can run it on a Windows machine or a Mac or a Linux or a Unix box without having anything powerful put on there. And it's also embedded into the Azure portal as well, so I can just log into the portal and run those commands from there. If you ask me, the thing that sets Microsoft aside from AWS, from Google, from any other cloud provider, it's the integration between Visual Studio and Azure that sets it aside. What we're able to do within Visual Studio is we can create resources within the Visual Studio environment and have those resources created for us in Azure. If I'm a software developer and I need to have a virtual machine created for me, why not have the option to create the virtual machine inside my software development environment? If as an organization I have particular architectural standards and practices that says SQL is my platform, I always deploy a 2-node SQL replica, I deploy 2 .NET framework servers as the front-end load balancer, I make that architecture available as an ARM template and I publish that as an artifact in Azure. My developers can then create the infrastructure for their application by just clicking one button in Visual Studio. Visual Studio Team Services is the collaboration tool that Microsoft creates for developers. It was reinvented about 2 years ago for Agile computing, and it's just been rebranded as Azure DevOps. The idea is that you host your infrastructure in Azure and your developers continue to work within Visual Studio, and Azure DevOps provides the bridge between organizing and planning what your developers do, controlling what they can and can't do, but it just means that you can take a project from being worked on by a developer, put it through testing, put it through test automation, and then deploy it into Azure based on approval gateways. What that means is we don't necessarily have to have anybody there doing the infrastructure piece for us in Azure. Our developers can provision everything they need straight from within Visual Studio. This is Azure Advisor. This is built into the Azure portal. So the idea is we come in and we check out Azure Advisor periodically, and it'll tell us what's going on inside Azure. We've got recommendations around high availability. If we've got any single points of failure where maybe we've just deployed one virtual machine, or maybe we've got an availability set that only has one virtual machine, it'll let us know about recommendations to improve the resilience of our solution. Security recommendations, have we got any connections open to the public network? Have we got any applications connecting without a firewall in front of them? It'll give us the recommendations we need to follow to improve the security for our environment. Performance recommendations in Azure Advisor are all about helping us get the most bang for our bucks. So if we've got a very expensive virtual machine not doing much work, Azure Advisor will give us a recommendation that says, resize that virtual machine to be about this size, you'll save money. You've got this storage running on premium storage, and it never uses the speed, change it to standard tier storage. Most importantly, though, we have the cost recommendations. So I can look in the cost recommendations and see a list of changes that I should make to resources in my environment that are going to save me money. And this kind of figure here of saving me $3,000 per month by just making 2 changes in my environment, that's not unusual. I was doing some pre-sales work with a customer last week that periodically spends €1 million per month within Azure. We ran Azure Advisor for them, and bearing in mind this stuff is implemented by default in Azure, we came up with a list of 22 changes that are going to save them €275,000 every month by just sizing things correctly and using the right size of offerings for us. That's what Azure Advisor does for us. So let's talk quickly about some of the solutions we can build on Azure. Now I know there are a lot of bullet points here on this page, but the idea here, what I want to come across to you is Azure gives us a platform to build solutions on. So the good people at Microsoft have engineered entire platforms that we can take and consume. The idea being, if we have some of these components that already exist, I don't need to reinvent the wheel. I can just take a collection of these resources together and build a particular solution. And all I need to do is customize the areas where I need to. And the amount of development work I have to do is limited. And as you can see, quite often that might involve a combination of platform as a service offerings, some software as a service offerings, and potentially IaaS components working together. Azure Internet of Things is about taking telemetry and readings or insights and data from a large number of distributed devices, basically things that send information through. These are all the components that come out of the box within Azure that will allow us to support that. So we can see here we've got offerings in Azure that allow us to support the drives. There's even a free version of Windows 10 to run on Internet of Things enabled devices. There's a security program. They've got a certification program for devices to make sure the devices are available. We've got core IoT offerings that give us a mechanism to consume huge amounts of messages from lots of devices quite quickly in a secure way and to provide analysis based on events of what's coming through. The idea here is pretty much all the challenges we face in building a large-scale IoT solution have already been dealt with for us. We just need to focus on what's the data we want to pull in and what do we want to do with it. This is what an Azure Internet of Things solution looks like. We have some kind of equipment or things outside in the real world generating telemetry. And what we want to be able to do is pull that information into some storage, organize it, track it, and report against it and have it do things for us. So over and over again, when people are building IoT solutions, I did some work with Shell a couple of years ago, and that was literally 75% of the solution was already there and built for them in Azure. They just had to take offerings and just add some individual bits of code and workflows that made the whole experience work for them. So as you get familiar with Azure, you're going to see things like Hadoop, table storage, machine learning, the IoT hub, and custom code they develop. You're going to see these building blocks coming together to build technologies and solutions for customers. Azure Big Data Solutions, they're based around, again, using a combination of components that are readily available within Azure. So we have information management offerings like Data Factory, Data Catalog, and Event Hubs. These are basically designed for processing and onboarding large amounts of information and cataloging them. Then we've got facilities for storing large amounts of data. So we've got this thing called the SQL Data Warehouse, which is a large, historical, analytically optimized data warehouse where we can store data. We've also got data lake storage, which allows us to store huge amounts of tabular data as well. Then we've got AI offerings that allow us to learn and develop algorithms to deal with particular circumstances and solve problems. And we've got intelligence services like cognitive services that'll do text-to-speech, speech-to-text, image recognition, Cortana for voice-enabled searching and context-level searching of stuff and indexing. We've got a bot framework which will allow us to create code and personalities for software that will interact with human beings, usually through like a chat type interface to answer questions and fulfill orders for them. And then we've got the visualization and dashboard capabilities of Power BI built into the system. So the key lesson to take away from this slide is pretty much everything you want to have to build a big data solution. There's an offering component there in Azure that you can build upon as a foundation for this stuff. AI is a huge growth area, and again, just like these other areas, there are various domains of capabilities that organizations need to have to create an artificial intelligence solution. And Microsoft have created these things out of the box to solve a lot of the challenges you need to create this stuff. So what I'm going to do now, just to close out today's selection, is to quickly show you a demonstration of an Azure AI solution. So this is something that you can actually take for yourself from Microsoft and deploy yourself in your test subscription. This is really powerful. So in your own time, if you could go out there and take a look at this, I'm going to search for something called Jfk Files in Google. And I spelled that wrong, so Google tells me to spell correctly. So I'm going to go to the Jfk Files here. Now this is an application that's created on Azure by Microsoft. What happened was back in 2013, the US government had to disclose all the information they had on the JFK assassination. They had to disclose that because the 50-year period of secrecy was up. There was about 50 terabytes of printed documentation, audio recordings, video files, notes, and records about the whole JFK assassination that were made available. The good people at Microsoft developed the Jfk Files application as a way to search through that information. This is really, it's a bit of a toy really to show you what you can do with artificial intelligence. But I'm going to bring this up. I'm going to do a search on Lee Harvey Oswald, who, depending on who you speak to, is the man who shot JFK. And I'm just going to search on his name. Now what's happening now is the JFK applications is going through about 50 terabytes of documentation, of records, of video clips, and is giving us a list of anything that pertains to Lee Harvey Oswald. So you can see here we've got some old school typing there, and it's done character recognition to find Harvey Oswald's name in there. If I go back to the previous page, if I go back to the first page again, there's something really cool happening here. Oh look, somebody has written the word Lee Harvey Oswald in a report in handwriting. There's a Microsoft Cognitive service that does handwriting recognition, and it's analysed that document and indexed it. And that turns up in my search results. So we're searching much more than just records in a database here. We're searching documents. We're searching a huge number of artifacts here to pull back context about a particular thing. I can also visualize this search as well. What I'm able to do here by clicking on this view over here, I can see the relationship between Lee Harvey Oswald and other entities within this data set. If I come down here into the view, down at the bottom, I can see all the various objects. So I can switch between Alvarado, November. Let's suppose I search on something else. So Lee Harvey Oswald was a US Marine. So I search on the US Marine Corps in here. I'll see any references to that, and I'll see the relationship between the USMC and what involvement the US Marine Corps had in the investigation, and so it's getting these implied relationships between things in there. Now, what's really cool about this Jfk Files app, not only is it in there and it's using Azure, not only is it using Azure AI services to build this stuff, but what you can do is you can come along here and you can take the code they've used to build this application and you can deploy your own version of it. So here, for example, here's where Jfk Files are doing facial analysis of pictures, and it's pulling up a match of any pictures in there to do with Lee Harvey Oswald. So have a play with this stuff. All right, go to the Jfk Files website. Come along, have a play with it. I'm going to send out some instructions for everybody to follow to provision your own trial Azure tenant. It's actually quite a simple process, and I'll run through that in a second. But then you'll be able to deploy the Jfk files into your own Azure tenant. Now, fortunately, all the documentation, isn't contained in this app. When I come along and I do a search on the Jfk files, all this data that's on there is just out there on the public internet. It's only the searching engine and the context that gets held in my app. I can host this for about $3 per month in my own Azure tenant. You can create your own version of the Jfk files. Have a play with the stuff, have a bash at deploying it in your own environment. Just look at the Jfk Files website and just follow some of the instructions for that. So, to close out today's session, what I want to do is finally just show you how to set up an Azure free trial subscription. This is actually a lot easier than you might think. This is a testament of just how easy Azure makes things. What I'm going to do, I'm going to create a new browser window. And what I need to do is I need to have a Windows Live ID to be able to create an Azure tenant. So it might be that I start off by going to, if I don't have a Live ID already, I go to outlook.com. I'm going to create a free account here. Now I strongly urge people not to use your DXC mail account to do this. Go away and create your own free account. So I'm going to call myself Rouge, is French for red bear. I'm going to create a password for that. And put my name in. My date of birth. Maybe he wants to send me a birthday card. Can always handle more hate mail. Well, I now have an Outlook.com mailbox, and I have a Windows Live ID account. There we go. What I'm going to do now is I'm going to go to Azure free trial site. This is quite good because we get a free 12-month subscription for Azure. So I'm going to start for free. What I'm going to do here, I'm going to make sure I sign out with my DXC account. I'm going to sign in using that account I just created. This free account I'm creating is going to give me $200 worth of free credits for the first 30 days. After that, I'll still get access to a whole bunch of free offerings as well for me to learn with as well. But in the first 30 days, I'll have £200 of credit. I need to put some more information in here. And what I do need to do is I do need to provide some credit card details. The reason why is Microsoft isn't going to debit my card for anything, yeah. But what they are going to do is just validate that I'm a real person, because they can't just go and give me free accounts ad infinitum. as it says here, you won't be charged unless we upgrade to another offering. So I'm just going to very discreetly put my own credit card details in there. Put in my card's expiry date, etc. And then when that's done, I'm just going to hit next. Sorry, apologies if I haven't moved that stuff off the screen, but I just need to make sure I'm not sharing my card details with anyone. And then once that's done, I can just click next, and that will create an Azure tenant for me. I just need to accept the terms and conditions of the license. And then what I can do is come along to the Azure portal. And I'll then be able to log in using that account I created. Hey presto, I'll be able to go in there and create whatever resources I want, up to a value of $200 in the first month. But remember, there's a whole bunch of stuff in here that's free, like function apps, storage accounts, web services, cognitive apps. There's a whole bunch of stuff you can take and run here for free for educational purposes. So whilst that $200 is limited to your first 30 days, the stuff you do with that onwards from there, you're just limited to the free resources. But you can keep going with that stuff. So there you go. That's how to create an Azure subscription. Again, please do make sure that you don't use your DXC email account for this. Yeah. If you want to use your DXC Amex card to create a subscription, check with your line manager. They may or may not want you to do that. So always get your line manager's approval before considering doing that. Don't try doing labs in a customer's environment, or don't try doing the labs in an environment where it's connected to anything for production use, because that's just not good practice. Always use a free trial account. There's nothing stopping you at the end of the month signing up for another free trial account. You can use the same credit card details. All you have to do is use a different live ID account to set up and run with that. So, before we start the next module, if you guys can take the time out, create a live ID account, yeah, and create yourselves an Azure tenant using the free trial option. Then when we come into the next session, we'll be able to do some labs where I get you guys to build some virtual machines and some resources. But that's everything for this section. I am very well aware that people have been sending me questions for the session. So what I'll do, because I've got somewhere in the region of about 116 questions, I'll create over the weekend a frequently asked questions section and share that out with everybody. And then as we go through each of these sessions, I'll collect all the questions you guys ask, and then we'll send the results out. Okay, guys, thanks very much for taking the time to attend this session. Do set up that free trial account, and I will see you all on the next session. Thanks very much for your time.